Okay, today we're going to talk about compound interest. We're going to talk about compound interest using exponential growth and exponential decay. So the first part, we're just going to talk about growth. So a lot of times it's like whenever you put money into a bank account, how you like gain interest. And so your bank account grows and actually grows exponentially. And this is assuming that you don't take money out, you don't put more money in, stuff like that, variables like that. But we'll talk about some of those real world problems. The thing that you need to try to get to memorize is the formula. So A equals P parentheses 1 plus R over N parentheses to the NT power. N and T are in the exponent. Okay. A is the balance after T years. So it's the amount after so long. So that's why we call it A. It's because it's the amount. P, the reason we call it P is because it's your principal. Principal is your starting amount. It's the amount that you deposit in your bank account. It could be the starting value of something before it like we'll see an example about baseball cards. They increase in value. So P would be the starting amount, like what you paid for it, and then what it increases to be, what the value increases to be. R is the interest rate. Now the thing about your interest rate is you want to keep it in decimal form. So in your problem, you'll get it as a percentage and you have to change it to a decimal. Okay. N is the number of times the interest is compounded per year. So if it says that it's compounded annually, that means once a year. My N would be 1. It happens one time a year. Semi-annually, it happens twice a year. So my N would be 2. Sometimes you'll hear about quarterly interest. So quarterly happens 4 times a year. So my N would be 4. Monthly happens 12 times a year, 12 months in a year. We won't get into weekly, bi-weekly, stuff like that, but it's just how many times it happens in 1 year. T is the number of years interest is compounded. And so they'll tell you how many years usually, or if we're trying to figure out how long it's going to take for our investment to be $50,000, if that's our goal, then you might have to figure out what T is. But all of these problems, I always write down A equals P equals R, N, and T. So I make sure I cover every single part of that formula. Okay, so let's look at example number 1. It says the amount of $500 is deposited into an account that pays 9.5% compounded monthly. What is the balance in the account after 3 years? Okay, so what we're trying to figure out is the amount after a certain time. Okay, that's our A. So I put a question mark there. That way I know what I'm solving for. P is the principal, so it's what you put in the bank at the very beginning. And here, the amount that was deposited is $500. Okay, that's my principal. R is the rate, and my rate here is 9.5%. That bank is going to pay me 9.5% every month. So if we're going to put that 9.5% into a decimal, what you're going to do, I don't know if y'all remember or not, that decimal is going to move to the left 2 spots. Okay, so my rate is going to be 0.095. That's what I'm going to use. I'm not going to use the 9.5. We want it in decimal form. Okay, my N is the number of times it happens per year. So if it's compounded monthly, it happens 12 times a year. T is the amount of time, and it tells us we want to figure out after 3 years how much money is in that account. Okay, so I have everything filled out. Now I'm going to plug it into my formula. So A we don't know. P is 500, parentheses 1 plus R is 0.095 over 12 to the 12 times 3. Let me write it bigger so y'all can see it. There you go. Now it's a little easier to see. Okay, and so we can put this whole thing in our calculator. So you're going to put it in exactly how you have it written. Once you get to the exponent, you're going to put caret 12 parentheses 3. Make sure the 12 and the 3 are little in your calculator, that they're in the exponent. Okay, so go ahead and punch that in. 500 parentheses 1 plus 0.095 divided by 12. Close your parentheses. Caret 12 parentheses 3. Close your parentheses. Okay, and we're talking about money. So whenever you talk about money, you're going to round to the nearest penny. Okay, so that's 2 decimal places. Okay, so it's going to be $664.14 when you round it. Alright, okay, on number 2, it says your collection of baseball cards cost you $150 in 1988. In 1994, the value of the collection had increased by approximately 7.5% each year. What is the value of the cards in 1994? Okay, so we're trying to figure out the amount after a certain time, which is A. Okay, our principal is what we started out with, and we paid $150 for those baseball cards. Our rate is 7.5%. So if you put it as a decimal, it's 0.075. We just move that decimal 2 spots to the left. Okay, N is the number of times it happens every year. And it says it's increased by approximately 7.5% each year. That means it happens 1 time a year. So my N is 1. T is the number of years. So if we're going from 1988 to 1994, how many years is that? 1994 minus 1988. And that would be 6 years. So we're trying to figure out the amount that the baseball cards are worth after 6 years. Alright, so now let's plug it into the formula. Go ahead and punch it in, see what you get. And you should get $231.50. Remember, talking about money, you went around to the nearest penny.